So today's lecture is actually a supplement to our normal exception handling lecture. The reason I created this lecture is a lot of students just still had problems understanding, how to handle exceptions, where they should be throwing exceptions, and where they should be handling exceptions. So hopefully this lecture sort of helps you sort of figure out your assignments and how they should be coded. So I've just created this sample WPF app. It's got a button that has a click event in it. So before we code anything here, let's pretend as if we're just going to create our business logic. So I would come over here, create a class. Maybe we'll call it CLS car, because that's one of our classes we've been using for our vehicle and car class. So now once we've done that, I'm going to take this class and let's just create some public methods now. So public void my method A. We'll do underscore A. What we're going to do then is have my method A call a private method, my method B, which will then call another method that will make private, method C. So that way we have some kind of chains of calls with our code. So what we want to have happen is that we know that A is going to call B, B is going to call C. So let's start at the bottom level here. So because this isn't a class, we know that all of these methods are going to be called by other methods. They're lower level methods. So we always want to raise up the exception. So it's really easy. All we do is try tab, tab, and this is going to put our exception handling code in here. And so we can just do something like this. So now the idea being that, okay, we've got this exception, but now we want to throw that exception so that it's raised up to these other methods, to where it eventually will be handled by the final method. Now, in previous lectures, I had some code that we'll just go through, and all you have to do for your assignment is just paste this in, and you're done. So what this does is this is going to allow us to create that breadcrumb trail for our exceptions so we can see which class it's in, which method it's in, and that chain that gets called. Now when I pasted this in here, you'll see that method info is giving us an error. So to solve it, we highlight it and we say, okay, what's really going on here? And it's like, oh, it just needs a using statement. So let's click that, and there it goes. It puts our using statement, and now it's happy. So what's going on here now is that we're saying this is what's called system reflection. So we're saying for our method info, get the current method. What's its declaring type? Well, its declaring type is CLS car, and that's the name of it. So this just returns CLS car. I made up a character dot, just so I could say this class name dot. Here's my method info, where I'm just going to get the name of the method that I'm in, and I'm going to add on whatever exception occurred. So for instance, if a divide by zero exception happened here, so if I had something like this, and then I said, int k equals I divided by j, something like that, that's going to have a divide by zero exception. When that happens, it's going to be caught here, and then we're going to throw that exception up to the next level. So what's the next level? Well, this method is going to be called inside here. But before we can do anything, we want to put a try-catch block here. And you'll notice that, again, this is just a copy and paste everywhere I go. So I take this, now I put a try-catch this. Oh, and what I do anytime I create a method, before I put any code at all, I just copy and paste this in there, and I'm done. I don't have to do anything else. Now, again, in the real world, you don't have to do it this way. This is a way that I made up. I'm not trying to tell you this is the only way to do it, or this is the right or wrong way to do it. For this class, the reason I'm mandating that you put try-catch blocks in every single method is because I want you to learn about them. That's the point. When you get into the real world, or you get into a particular team that you're working with, you decide on standards like this, on how you want to handle try-catch blocks. Some philosophies say no method should have try-catch blocks. Other philosophies say every method should have try-catch blocks. I'm not going to tell you what's right for your project. I'm just trying to educate you on how to use try-catch blocks. So I'm trying to show you how to to position them. I'm also trying to teach you, ways of creating breadcrumb trails, kind of a little bit more creative way to do this. There's also ideas that you only want to use try-catch blocks where you know the exact type of exception, so that some people believe you should never catch a generic exception like we're doing here, the top level, the base level class for all exceptions. You should only use try-catch blocks if there's, or people would say that you should only use try-catch blocks if you know the exact, like a divide by zero, like down here, or file not found exception, or something that maybe you're trying to access a file and you know that this particular type of exception possibly could handle, so you only handle that type of exception here and not have this generic catch-all. Again, there's different philosophies. You do what's right for your team. This class, we're trying to be educated on how to use them. So with that said, this is the way we've chosen to do it. You can kind of do it your way, but again, this is a way. Just be consistent. And so now let's go ahead and let's do our complete call chain. Well, there we go. Now we're done. So we've got method C that's called by method B, which is called by method A. When the exception happens here, it's going to raise that exception up through its ranks all the way up to this method A. So now let's actually use this class. We come back to our main window, and if I start typing CLS car, we can call it my car equals a new car, and then we can say my car dot method A. Now I made these other ones private on purpose because the outside world, you have no idea they even exist. But the breadcrumb trail allows us to see that, yeah, the user did call method A, which called method B, which called method C. And maybe there's a reason that that call chain or method C only generates this exception if this exact method chain is called. There could be other times where this method C is called, but maybe it doesn't generate. Maybe there's some other state that's set in these other methods. And so that's why it's so important to know how the exact path that these exceptions occurred in. So now over here, you'll notice that what's going to happen if I just run the code this way? Well, let's find out. So I'm going to run the code. We're going to click our button. And now look what happens. So as I do this and I press F10, see how it just shut down? Well, why did it just shut down? Well, we threw the exception right here from method A, but notice we didn't handle it anywhere. So our program just crashed. That's exactly what we don't want. Now, it's next to impossible to make an application that has 0 bugs in it. And that's why I personally like to put try-catch blocks almost everywhere, because it's just saved my butt so many times because I have bugs in my code. It's impossible to have bug-free code. No, I mean, it just no one does it. And so that, again, is why I like to put these try-catch blocks everywhere, because they help me catch my problems. And a lot of times, let's say that whatever happens here in this particular example, I can then have this try catch, and I could maybe revert my program back to, I could reinitialize things, bring it back to some safe initial state that I know about that should most of the time be working correctly. So that's like this top level method. If something bad happens, I want to alert the user, reset some state, do whatever makes sense for my application. So now what's going to happen is this is a top level method here, this button click. So it's where we actually want to catch and handle the exception. So I'm just to save time, I'm just going to copy and paste a method that we had before, this handle error. And again, this could be anything. Now, more than likely, again, you probably want to put this in a separate class that's some sort of error class that you pass this data into. That error class takes care of, presenting a message box or writing into the file or whatever it is. Now, this top level method, what we want to do is instead of actually raising the exception up, we actually want to handle the method. Now again, here's that method info. We have to add that using statement to the top. So we'll just click that. It adds the using statement, and now it's happy. And so now all we're doing now is we're calling handle error. We're passing in the name of the class and the name of the method. And then we also pass in that string message, which is our exception. And this is our breadcrumb trail. And so now when I run this application and some sort of error happens that we're not privy to, that we weren't expecting, you can see now I have a message that tells me, okay, in the main window, I clicked the button click method. Then it called the car class and it called the method A, which then called method B, which then called method C, which had an attempted to divide by 0. Now you'll notice that again, this class could have called another method in another class. That's why I put that class name first, because you know it could have vehicle dot toString or vehicle dot method, and you want to know exactly that call chain. So now when you're debugging your program, it may be hard just to look at method C and know where that exception came from, but it might make more sense if you actually know this full call chain. So this is how I then set up my exception handling. So again, every method you create, just put the try-catch blocks first and then copy and paste this. Now if I were to add another button onto my application, I would do this exact same thing because it's a top-level method calling these other lower-level methods. Now if I had a private void test method, now this is behind my UI, but which kind of exception handling should this have? Well, let's pretend that this is called here. So is this a top level method or a lower level method? Well, it's lower level. So all we do is we come in here, just copy this, whoops, and then we'll just paste it right here. Okay, let's try this again. Come back over here, copy this, paste this here, obviously delete this, and now we're ready to run this, or actually code this test method, and we're going to throw that exception up to wherever it happens. So hopefully that helps a little bit with the exception handling, and just let me know if you have any questions.